right, checking your understanding on example 4, which we finished in the first video. It says, describe the situation pictured after 4 years. So if we look back here, we knew that it hit its equality at about 3.3 years. That's when you saw the graph and it passed it. So remember I said anytime after that, it now means that the car is worth, so the car's worth is greater than what the person owes on the car. All right, example 5. It says a car exponentially depreciates. So I'm going to go ahead and put my variables on the side as we've been doing all course. It exponentially depreciates at 6% per year. Beth purchased a 5-year-old car for $18,000. So when the car was 5 years old, it was worth $18,000. So we're looking for the new car price. So remembering our formula of y equals a times 1 minus r to the x, let's plug everything in. So I know that $18,000 goes there, and it equals, a is our unknown, 1 minus 0.06 to the 5th power. Now when I take 1 minus 0.06, I actually get 0.94. And 0.94 to the 5th power, let's go ahead to the calculator, and I've got 0.94 to the 5th, gives me 0.7339. So I get 0.7339 times the new car value equals 18,000. So my last step is going to be to divide both sides by 0.7339. So going back to our calculator, we get 18,000 divided by 0.7339, and we get a car value of $24,526.50. So this was the new car value. So if they had purchased it brand new, that's how much they would pay for it. All right, please work this one. Press pause when you're ready, press play, and we'll get going. All right, let's see how you did. Let's go ahead and write down our variables. And it says here that a car depreciates exponentially at a rate of 5%. If the car is worth $30,000 after 9 months, what was the original price of the car? Now, 9 months. Some of you are going to just write 9 there and calculate it based on that. But the problem with that is that its x is time in years. So you need to get that into terms of years, which is 9 divided by 12. It's 9 out of 12 months. So x should actually have been 0.75. Plugging that into our formula now, we have 30,000 equals a times 1 minus 0.05 to the 0.75, period. Once I break that down, here, this subtracted is 0.95. So we're going to take our 0.95 and put it out to the 0.75, and we get 0.9622, or 9623 actually if we round, equals the 30,000. Our last step, we're going to go ahead and take that 30,000 and we're going to divide it by the 0.9623, and we end up with 31,176 $31,071. So it was $31,175.31. And that was the car's new value. All right, last example for this unit. So we'll go ahead and identify our variables on the side as we've been doing. And it says Leah and Josh bought a used car valued at $20,000. When it sold new, it was $24,000. If the car depreciates exponentially at a rate of 8%, approximately how old is the car? So there's our question mark. So plugging in my values, I've got 20,000 equals 24,000 times 1 minus 0.08 all to the x power. So let's do some of what we can. The first thing we're going to do is divide both sides by 24,000. And we're going to go ahead and leave that in terms of that for right now. So I've got 20,000 divided by 24,000 equals, and 1 minus 0.08 is 0.92, so it's 0.92 to the x power. Now, we've got a little issue whenever we have a variable in our exponent, and that's when we need to use our natural log. So if we look on here, natural log is that one right there. Let's go ahead and clear this out. So I'm looking at the natural log. Let's do this first. We've got 20,000 divided by 24,000, and it's the natural log. So I get for that portion 0.1823 equals, and going back there, I've got 0.92 and the natural log there. So it equals, and this was negative, and this one also is a negative, and it's negative 0.0834. And what happens when I take that natural log is it brings my x value down. Now I'm simply going to divide my values, and when I do that, I end up with 2.19 years. So the car is just a little bit over 2 years old. Just to kind of verify that, let's put it into the calculator. So I have 0.1823, and it's negative. And then I'm going to divide that by 0.0834, which is also negative. And you can see here that I have a value of 2.19 years. And so why I did that, looking at getting x by itself. So that's why we divided both sides by the 0.0834 in the negative. All right, your turn. Go ahead and give this one a try. When you're ready, press play and we'll finish it out. Okay, let's see how you did. So first, let's go ahead and identify our variables, what we know and what we're solving for. So it says, how would the car in example 4 have been purchased? How old would the car have been in example 4 if it had been purchased at half of its value? Well, if we look back at example 4, the original car sold for $26,600. So if I were to take $26,600 and divide that by 2, I would have half of the car's value, which is $13,300. So Y is going to be $13,300. And we knew that the interest rate was at 5.5%, so as a decimal, it would be written as 0.055. Plugging that into my formula, I've got 13,300 equals 26,600 times 1 minus 0.055, all to the x power. My first step, I'm going to go ahead and divide both sides by the 26,600. And I get basically 0.5 on this side because it was half equals, well, 1 minus 0.055 is 0.945, and it's all to the x power. Remember now, the next thing we're going to do is actually take the natural log of both sides. So let's go ahead and go to the calculator. So the first thing is going to be the natural log of 0.5. So I got negative 0.6931. And then we'll go ahead and take the natural log of the 0.945. And I get 0.0566. And remember then that allows the x to come down. Both of these are negative, so I'm going to divide both sides by negative 0.0566. And plugging that into the calculator, I get 0.6931 in the negative, divided by 0.0566, also negative. And I find that the car's age would be 12.25 years old. This was one of the tougher lessons, so good job everyone for sticking with it.